In any triangle, show that the perpendicular bisector of the line joining the feet of the altitudes drawn to two sides bisects the third side. Let's draw the diagram first. You probably already know this. Drawing a neat diagram helps you get a better understanding of the problem and gets you to the answer fast. We have triangle ABC. CD and BE are altitudes and FG is the perpendicular bisector of DE. We need to show that G is the center of BC. Just looking at this figure, you can straight away say that BC, D and E should all lie on a single circle. Why? So we have two right angle triangles here, BEC and BDC, and both of them have the same hypotenuse. So whenever you see a line segment which is the hypotenuse of two right angle triangles, then all the vertices would lie on a circle and the hypotenuse would be the diameter of the circle. Let's see how we prove that. Let's look at a right angle triangle first. Let O be the center of the hypotenuse BC. Join O with D, D being the right angled vertex of the triangle. Now draw OP parallel to DB and OQ parallel to DC. Right? So if this is the center, then both these sides are equal. Let's call them R. And then we can use the basic proportionality theorem to show that PC equals DP. Why? Because PO is parallel to DB and therefore OC by OB is equal to PC by PD. That's the basic proportionality theorem. And since these two are equal, these two also must be equal. Similarly, you can show that DQ is equal to BQ because in this OQ is parallel to DC and therefore OB by OC must be equal to QB by QD and therefore these two must be equal. Now look at these two triangles, OQB and OQD. Both of these are right angles because OQ is parallel to DC. This side is equal to this side and this side is OQ is common to both. BQ is equal to DQ and OQ is common to both these triangles. And therefore OQB and OQD must be congruent. Right? Both of these are right angle triangles and they have the same two sides. In that case, OD equals R. Right? So when you join the center of a hypotenuse to the opposite vertex, the one with the 90 degrees angle, you actually form two isosceles triangles. That's a useful fact to remember. When the center of the hypotenuse is connected to the right angled vertex, two isosceles triangles are formed. Right? We show that OD equals OB. Now add in one more right angle triangle to this diagram here, like this. Just like how we did earlier, we can show that OE is also equal to R. So B, C, D and E are all 4 points which are equidistant from O. Right? So B, C, D and E must lie on a circle with O as the center. That's what we said earlier. So you must remember these properties Though they might look very trivial, it's useful to remember them so that you can directly apply them when you look at such figures. Properties such as this and this. So since B, C, D and E are on the same circle and BC is the diameter, DE is a chord. We know that the perpendicular bisector of a chord passes through the center of the circle. Right? That's a straightforward proof. We are not going to do it now. And since FG is the perpendicular bisector of DE, it should pass through the center of the circle. Since BC is the diameter, G must be the center. Right? Because if this were to pass through the center of the circle, when you extend it, it becomes a diameter, and the point of intersection of two diameters is the center. And therefore, G bisects BC.